here are the chapter 6 section 1 notes. I saved all of the notes for you guys, 6.1 through 6.3. We're only going to do page 1, 2, and 3. So when I was doing these notes and trying to learn this myself, colors helped me a lot, and I'll show you kind of what I mean by that. As far as choosing which integral you're going to do first, we're going to find the area between two curves. So if I would make F this purple color, and then G, I need to sharpen these, this green color, and we want to find the shaded region in between them. The one that you put first is the one that's on top. So the F equation is up on top of the shaded region, so that's why they do the F. And then these points right here is your X is equal to this. You have to know when they intersect. That's like the bottom of your integral number, and then this is the X value for B. So let's go ahead and try this with example 1. Find the area of the region bounded above y equals e to the x and bounded below y equals x. Now, you guys see that space would continue on forever, so they did give us a boundary of 0 and 1. So this one I don't feel like I need to use two different colors because it's pretty obvious. E to the x is on top, and this line y equals x is here. And then the shading is kind of hard to see. Oh, let's use a color. So we're shading right here just between 0 and 1. Okay, so we're ready to go. You guys should know how to do this. If we wanted to integrate this, e to the x stays e to the x, and we're going to evaluate at 0 and 1, minus, if we integrate x, it'll become x squared, but we would want to multiply that by 1/2 to get us back to where we started. And we're going to also evaluate that at 0 and 1. So what this is really going to be is e to the 1 minus e to the 0 minus, and if we plug a 1 in here, it's going to be 1/2 times x squared, so it'll just be 1/2 and then minus 0. So e to the 0, anything to the 0 power equals 1, and this is just e to the 1 minus 1 minus 1/2, so e minus 1.5. And that's roughly equal to, I have it on Desmos, let me look. 1.218. I notice in the book a lot of times, I hope you guys can see that. I notice in the book a lot of times they do the real answer, like e minus 1.5, where Desmos is going to give you this answer. All you have to do to verify them is just, I typed in the integral. Do you guys see how you can type it in on Desmos? You just basically type in what it says. And then here is your actual answer, e minus 1.5, and you can see that they're the same. So if you do want to use this answer here, just make sure you use the squiggly equal sign just to kind of verify that, you know, that's an approximate error, or approximate of their answer. So that purple region, 1.218 units are shaded. All right, let's go to page 2. So now we have two parabolas, and this is like exactly what I'm doing algebra 1 right now. Not the calculus part, but the parabolas part. So y equals x squared. I'm going to make this purple. And y equals 2x minus x squared is here. Let's do this blue color. Okay, so it's actually the blue one that is on top of the shaded region. So this is what we'll put in our integral first. But first we need to evaluate where these parabolas cross each other. This should be obvious that this point is 0, 0 right here. But where else do they intersect with one another? So there's a couple ways you can do this. You could just type both parabolas into Desmos and find where they cross. That's really easy. You could solve the equations and just set them equal to each other. But where these two parabolas cross is at the coordinate 1, 1. So be careful when you write this down that you put the function that's the top part of the curve first. So we're going to go from 0 to 1 because those are those x values. We're going to do the blue function first of 2x minus x squared. Remember to write dx. And we're going to subtract this 0 to 1 also of the purple x squared dx. Now what we could do here is we can combine them. It's a little bit faster to write it as 2x minus x squared minus x squared. And all of that dx. Maybe I should make those brackets. Okay, looking good. So we can simplify this as, so I'm not doing anything yet, just simplifying 2x minus 2x squared dx. And now let's go ahead and integrate. So x squared, and that turns back into 2x, that's nice. X to the third, but we want this to turn into 2 minus 2x. So what we would do is multiply by 2/3. So 3 times negative 2/3 is negative 2x squared. And we want to evaluate that from 0 to 1. Okay, so let's first plug in a 1. If you plug in a 1 here, you're going to have 1 minus 2/3 times 1. So 1 minus 2/3 minus 0 minus 0. So 1 minus 2/3 is 1/3. So it's just 1/3 of a unit. I know this is like really zoomed in, is shaded right there. All right, let's move on to example 3. For example 3, I went ahead and sketched this function, and that is with the help of our friend Desmos. Okay, so sketch the function. I think that's really helpful. And then to evaluate our integral, we need to know where they intersect each other. So they intersect at 0, 0, and they also intersect at 1.181. So these type of questions, you're going to need to use either your calculator or Desmos. It's worth it to use Desmos. It's so much faster than your graphing calculator. So we're going to write down those numbers. Okay, so to evaluate this integral, we are going to have to use substitution method we learned last week. I'm going to probably do that work right here. So I'm going to let u equal x squared plus 1. So du over dx, so the derivative of this would just be 2x. And then if I bring the dx to the other side, I have du equals 2x times dx. It's a little bit extra. So I have an x and a dx, but I do not have that 2. So remember, to bring the 2 over to the other side, you have to multiply by a half. So a half du equals x times dx. So I'm going to substitute this back into this first integral. Okay, so this x and dx just becomes 1/2 du. So I'm going to put the half here, put the integration symbol, x dx just became this 1 du, and then I'm dividing by the square root of u, because u is the x squared plus 1. Now, if I'm going to evaluate this with u, which I do think would be easier, I don't want to leave this 0 and 1.8. I want to say, hey, when x is 0, so you go back here, if x is 0, u is 1, and if x is 1.18, you just do 1.18 squared plus 1, u is 2.39. So these are the numbers that I want on this integral because it's in terms of u, 1.18 and 2.39. Now, this one we can evaluate pretty simply, so we don't need to do substitution methods. So we are going to keep these numbers the same. So I know a few of you guys were struggling last week. Notice this one's in terms of du, that's fine. This one's in terms of dx. So we're just going to solve them separately, and then we're going to get our solution. So if you think of this 1 over radical u as u to the negative half, so that's going to become u to the positive half, and I would multiply that by negative 2. So if you took the derivative of this, it would become negative, oh no, not negative, I don't want negative, apologize. It would become 1 u to the negative half. That's what we want. We need to remember this 1/2 is in front of this problem, and we want to evaluate this at the 1.18 and the 2.39. And we would just use our calculator and type this into our calculator. This one, let's take the integration of x to the 4th minus x. It would be x to the 5th, 1/5. 1/5 x to the 5th minus 1/2 x squared. And we're evaluating this part from 0 to 1.18. We're just going to type things in our calculator. Hopefully you guys saw my mistake here. I just changed that to a 1. So when x is 0, u is 1, and when x is 1.18, u is 2.39. I'm sorry if I confused anybody, but I fixed it. I paused and I fixed it. This 1/2 and this 2 will cancel out. So to evaluate this, it's like u to the half, which is radical u. So it's just radical 2.39 minus radical 1. That'd be this part. And here we're going to plug in our 0 and our 1.18. So this would be minus, I'm going to write this as 1.18 to the 5th. Does that make sense? Divided by 5. I think it's easier to write it like that. Minus 1.18 squared divided by 2. And do you see when we plug in a 0, they're both going to turn to 0. So that's just going to be a minus 0. All right, and then we just kind of type that into our calculator the best we can, and you get 0.785. I'm going to show you guys how you can do this kind on Desmos. For some reason, Desmos wants you to type in those functions separately, and then it works. I tried doing that with brackets, and it didn't. So, you know, you can split these up into 2 sections. Notice I have my 0 and 1.8 here because I left that in terms of f of x, because Desmos knows how to, you know, they don't have to do substitution method because they're smarter than us. But this is just another way you can check your answer and verify your answer. This one kind of confused me a little bit, but I encourage you to read page 426. I'm going to summarize that for you. But sometimes if your function, see how this says y squared? You could solve for y, but then when you end up square rooting, you have to do a positive and negative. It honestly is more work. Sometimes it's best to treat x as a function of y instead of y as a function of x. I know that seems confusing, but if you think of this, it's like a parabola, but it's sideways. But here's the rule that got me confused because I kept getting the answer wrong, is they consider x, so instead of like which curves on top and which one's on bottom, you think of them as which curve or line is on the right boundary and which one is the left boundary. So let's go ahead and show that with 2 colors. So if we're talking about this shaded region in here, this orange linear equation, it's obviously this one, is the right boundary. That's your XR. And then the left boundary of your shaded region. So instead of talking about which one's higher and which one's lower, you think of these as which one is the left bound and which one's the right bound. So this equation is your left boundary. Okay, and then, but when you kind of do this backwards, or I thought it kind of seemed backwards, you do the right minus the left, and then your integral numbers are where they intersect the y coordinate. So it's like what we've been doing. It's just, I don't know, it kind of hurt my brain a little bit. But once I had this written out and labeled everything, that made this a lot more, I guess, easier to understand. So first of all, to find our intersection points, it's like, where would this line hit this sideways parabola? So you can just set them equal to each other if you want, or we could just type them into Desmos, or however you want to do that. But this coordinate right here is 5, 4. They intersect at 5, 4 right there. And down here, they intersect at -1, -2. So think of what is your C and what's your D in this situation. And it's our -2 and our +4. And then we want to put our XR function first. So -2 to 4. And then our XR equation. For all of you guys who are cringing at my mistakes, they have now been fixed again. I should just redo this problem, but I'm not. We'll roll with it. Okay, redo. I should subtract the 6 and divide the 2. So this is 1/2 y squared minus 3. This is y plus 1. So I fixed it here. Get your pluses and minuses fixed with mine, please. And then I just kind of combine like terms. So I wrote this -1/2 y squared first. This y's alone. This is a +1 minus -3 would be 1 + 3. So that's +4. Okay, so now when we take the integration of this, this will become y to the 3rd. And we would put a -1/6 in front. So if you think of taking 3 times -1/6, you get back to -1/2 plus y squared 1/2 y squared plus 4y. And we're going to evaluate that from -2 up to +4. And, you know, do the math. It works out to equaling 18.